So to last class, we have started refraction. So the last topic was refraction through a compound plate, right? Hello. Last topic was refraction through a compound plate. Huh?
Yes, sir.
Yes.
Okay. So after the refraction through compound plate, the next is refraction through a rectangular glass slab. So see what happens when you have a rectangular glass slab. Let me rub it. I should put this diagram. Hmm. So say you have a rectangular glass slab. The thickness of the slab is T. The surrounding medium is air. The slab is made up of glass. Then again, the emergent medium is air also. This is the normal, and this is your incident ray. This is the incident. This is the angle of incidence. So your ray is traveling from air to glass. So when a ray travels from air to glass, how will this ray bend, Minashi? It will bend towards the normal, away from the normal, or it will not bend. What happened to this ray?
It will bend away.
It's moving from rare to denser. It will bend towards the normal. The ray will bend towards the normal. When the ray travels from rare to denser, it bends towards normal. And this angle is the angle of refraction. So in the absence of refraction, say if there is no change in medium, then there will not be any bending and ray would have travel in this line. So this is the direction of ray without any refraction. So this is the original direction of the ray. This is the incident. This is your incident. This is the direction of the incident. Now, again, the ray is traveling from glass to air. Now it's traveling from denser to rarer medium. So when a ray travels from denser to rarer medium, it will bend away from the normal. So the ray will bend away from the normal. It will go like this. This is the angle of emergence. And this is the angle of refraction again. See, if this is R, then this is also R. This is R. So if we did this in the last lecture also, if incident and the emergent mediums are equal, then incident ray and this emergent ray will be parallel. This is incident ray, and here this green one is the emergent ray. These two rays are parallel. This is the emergent ray. Now, what you are supposed to calculate, you are supposed to calculate the perpendicular distance between the emergent ray and incident ray. I'm saying again, incident ray and emergent rays are parallel. But see, there is a shift. This is incident ray and this is emergent. So the perpendicular distance between the incident ray and the emergent ray is known as lateral shift. You're supposed to calculate this lateral shift here. Is it clear, Akshay, Arpit? What
Yes,
is
sir.
lateral shift?
Yes, sir.
So lateral shift is just the perpendicular distance between your incident ray and the emergent ray. That's the lateral shift. Now you have to calculate this lateral shift here. So this is point A. This is point B, and this is the normally action. You're supposed to calculate L. If this is I, then this whole is the vertically opposite angle. So if this is I, this whole angle is I. And how much is this one? This one, this angle, this one?
I minus R.
Yeah, this will be I minus R. So if this is I, this is R, this leftover angle will be I minus R. So the lateral displacement is the perpendicular distance between the incident ray and the emergent ray. To calculate this angle, what we can do is we can first calculate sine of I minus R. In this right angle triangle A and B, what is sine I minus R, Hishma? This angle is I minus R. In triangle A and B, what is sine I minus R? Hishma, Noah, what is sine I minus R in this triangle?
Bn upon AB.
Yeah, Bn upon AB. Sine is perpendicular upon hypotenuse. Perpendicular is L, hypotenuse is AB. So we can say that sine I minus R is Bn by O. So Bn is L, and we call this as OBN. Let's call this point as O, not S. In triangle ONB, your sin I is Bn divided by O. Bn is L divided by OB. So your L is OB sin I minus R. But this OB is not given. Let's take another right angle triangle. This is another right angle triangle. Let's call this point as call this as A. Let's call this point as. So in this triangle OAB, what is cos R? Nabil, Nabil Ahmed. How much is cos R in this triangle OAB? Nabil, you're not audible. Nabil Ahmed, what is cos R in this triangle OAB? Hello.
Sir, OA by OB.
Right. Cos is base, which is OA, by hypotenuse, which is OB. So we calculated cos R here, OA by OB. OA is nothing but the thickness of the slab. Huh? This T is the thickness of the slab. This is the thickness. So you can write this as T by OB. From here, you can calculate OB. OB is T by cos R. Next, what you can do is you can substitute this OB, the value of OB in this equation. So when you do the substitution, this is T by cos R into sine of I minus R. So this is the formula for the lateral shift. I is angle of incidence, R is angle of diffraction. Is it clear?
Sir, I have a doubt.
Yes, Abid.
Where you took T, sir, like, should
T is
it
this.
be,
T
sir,
is
shouldn't
thickness.
it be like the length of the slab, sir, rather than thickness? Because thickness we take in other plane. Getting.
The thickness is the separation between the incident and this one. This ray. Incident and the emergent phase. See, the thickness means, Arpit, if you have used
Sir, but
glass
if you
slab in
consider it in the 3D, so then thickness is like the distance. From the
this is the same thickness that you are thinking about. It's not breadth, it's thickness actually. So if you take a glass slab, if you say that this is the glass slab, right? Just 1 second. This is the glass slab. So this is the incident phase and this is the emergent phase. So you incident a light ray like this, it will come through this phase. So this portion is the thickness. It's not breadth. Breadth is this.
Okay, oh, I got it.
Okay, do it. It's a good score, Nabil. You could have scored full, like the paper was. Section A means you lost marks in MCQs.
The thing is for down.
Can I scroll it now?
Yes, sir.
सर एक मिनट yes, sir.
Can you scroll? We can get directly the question numerical on this link.
Usually, you don't get numerical on this concept. We use this concept with other concepts. Like you use this slab with a mirror, you use this slab with apparent shift. But this is the derivation that can be asked in your exam. So that was about lateral shift in a glass slab. After glass slab, the next topic is real and apparent depth. That's very apparent depth and real. So you have written up to this this one lateral shift. Everyone have written up to here.
Yes, sir.
So usually don't get questions from glass slab, but this derivation is a part of stable, so we should do it. The next is apparent. This is a very important topic. In plane surface, this apparent depth and the next topic, which we call this thing, TIR, total internal reflection. Those are two very, very important topics. So what does apparent depth means? Apparent depth means you can understand apparent depth from this example. Like you take a container, a beaker, and you place the coin at the base of the beaker. So there is no water, nothing. If you look from here, the real depth of the coin will be dr. This is dr. But if you fill this beaker with water and if you observe the coin now, then this coin will not appear here. It will appear here. This position of coin is known as the apparent position. And if you talk in terms of ray optics, then this is the image. This is object. The rays coming from the objects gets refracted from the water surface. And due to that refraction, you get an image which is this. So the coin which was placed here is visible over this point. So this is the real position. And the depth of this position from the free surface is known as real depth. And this is the apparent position of coin, and its depth from the free surface is known as the apparent. This is that's the apparent depth. The medium in which the coin is placed is known as the incident medium. And the medium in which the observer, this is I, which means this is the medium in which you have observer. So the medium in which you have observer is the refracted medium. So this is the incident medium and this is the refracted. So is it clear now? Understand what does apparent depth or apparent shift in position means?
So can you explain again?
You have a beaker. There is no water in the beaker. You place the coin here. This is the actual position of the coin, the real position of the coin. Okay. Now you fill this beaker with water. The coin, the actual position of coin is here. But if you look at this point from this position, you will find that the coin will not appear here. The coin will appear here. This is the position of coin. And we call this as apparent position. Why this coin will appear here? This we will do in the next part. The first thing is, what does apparent depth means? This is the real position of the coin. And this is the apparent position of the coin. The separation of this actual position from the free surface is known as real depth. And the position of this coin, this apparent position from the free surface is known as apparent.
But if you will look it from the sides, it appears to be on the original position.
No, no, if you look it from here, it will not appear at the original place. If you look at this place. Why this
Okay.
happened, that we will discuss. So
Okay, sir.
everyone, is it clear what does apparent position and apparent depth means?
Yes.
So when you fill this beaker with water, you won't find coin here. You will see coin here. This will be the position of coin, and we call this as the apparent position of coin. Now, the question, why the coin which is placed at this point appears at this point? The answer is refraction. And how does this happen? This is the ray diagram. So this is your coin. You call this coin as your object. This is your coin. This is your object. This is your object. So you have to basically draw the ray diagram to see the position of image. So we obtain image when rays meet after refraction. This type of image is known as real image. And but if the rays diverge and you produce them in the backward direction, then they appear to meet at a point. We call this image as the virtual image. But we obtain image after refraction or after reflection. So see from this ray diagram, this is your object. The actual coin is the object. One ray is coming from this object normally. So this ray will pass without any deviation. It will go straight. Then you have another ray. You incident this ray here. When this ray passes from water to air, it deviates from it refracts away from the norm. This is the refraction. See, this ray is coming, incident over this point B. This is the interface. This is incident medium, which is water. This is refracted medium, which is air. So your ray is traveling from denser to rarer. When it travels from denser to rarer, it bends away from the normal. And this is the angle of refraction. This is the angle of. So this is one ray. This is another ray. These are the two rays which are coming from the coin after diffraction. So just look at these two rays, Minashi. These two rays are converging rays or they are diverging?
Sir, the diverge.
They diverge. So they will diverging rays will not meet anywhere. So they will never make a real image. But if you produce these rays in the backward direction, if you produce this one in the backward direction, they appear to meet over this. And this point is the image of your object. So the object which is actually placed here will appear over this point here. Your object will appear. This is the image of the object. So the position of object shifts due to refraction. So this is the angle of incidence. This is the angle of refraction, this one. This is incidence. If this is refraction, then this is also refraction. This angle and this angle have corresponding angles. If this is I, then this is also I. Alternate angle. From the surface to the object is the real depth. From the surface to this apparent position is apparent. And the separation between the real position and the apparent position is known as shift. This is the distance through which your object shifts. This is refractive index of incident medium. This is the refractive index of refractive. Note it down, please. Just draw the ray diagram, then we will start the calculation. Draw this diagram and then the next. Akshay, Alia, Nabil, Ishma, is it clear? Both the diagrams?
Yes, sir.
Yes, sir.
So first diagram simply tells you what does apparent position and apparent depth means. And the second diagram tells you why it happens. It happens simply due to refraction. Tell me once you have written, I'll scroll it. In diffraction through plane surface, this is a very important topic. Okay, on Wednesday, you have a test of chapter number 3, current electricity, after the class. So from 10 o'clock, 10 p.m. onwards, I'll take a test of current electricity. If anyone want to give that test early, he can uh, give that test from 7:30 onwards. Please note down the syllabus. Chapter number 3, current electricity. So this Wednesday current electricity, next Wednesday it's magnetics, then EMI, then AC, then wave optics, and this is how we revise the whole syllabus. Yes, written, everyone. Noha, Yashika. Can I scroll it now?
Yes, sir.
Yes, this Wednesday current electricity. Draw the ray diagram also.
It is subjective.
Yes, both subjective, objective. And during test, you all have to switch on your videos. I'll be using focus mode, so you can't view each other, nor your video will come into recording, but you have to switch on your videos. And I will take, I or any other teacher will also take Viva after the test. So please don't try to copy from that. So if you don't perform in Viva, we'll scale down your marks. Ishma, Anshika, is it clear? This apparent depth, the concept of apparent depth?
Yes.
Yes, Anshika. Written?
Sir, I'm writing it.
See, while drawing this ray diagram, mark these angles very properly. Huh? This is R, this is R, this is dotted line. The arrows are very important in ray optics. This A to O prime is the apparent depth. This A to O is the real depth dr. This O prime is the shift. We have to derive a relation between dA, Ni and Nr. Dr, D, and I and Nr. So it's simple geometry. Just use two right angle triangle and that's it. Two right angle triangle plus Snell's law. Anshika, just tell me once you have written, I'll start the calculations.
Sir, what is that top right corner, sir? At VI something. Well, above the NR.
Above, yes, the above one is Nr. The medium in which you have the observer is Ni. And the medium in which you have the object is Ni, incident. Can I scroll it now?
Minute, sir. Done, sir.
Sir, wait, sir.
In ray optics, the major portion is this ray diagram. If you can draw this ray diagram properly, then the calculation is straightforward. Just two triangles and one Snell's law. That's it. Tell me once you have written. Nabil, Anshika.
Done,
Written?
sir.
Okay. So see this triangle OAB. This OAB is a right angle triangle. Anshika, what is sin I in this triangle? In triangle OAB? I need sin I in terms of ratio of sides in OAB. What is sin I?
Sir, AB upon BO.
Right. Sin I is perpendicular upon hypotenuse. So perpendicular is AB, hypotenuse is OB. So this is AB by OB. Similarly, if you take this triangle O prime AB, what is sin R in this triangle, Arpit? O prime AB. How much is sin R?
Sir, OA, sorry, O prime A upon O prime B.
AB upon O prime B, right?
Oh, sorry, AB.
AB upon O prime B, that's sin R. If I take ratio, sin I by sin R, then you have just O prime B by O prime B divided by OB now. Now, after this step, I'm using a approximation. I'm using the approximation that this B and A, these 2 points are very, very close. Again, just look at the diagram. I'm saying that this point A and this point B, these 2 points are very, very close. If these 2 points are very close, then O prime B can be written as O prime A and OB can be written as OA. So this is the approximation that near normal incidents we call this, and A and B are very, very close. So if they are very close, that means OB will be equal to OA and O prime B will be equal to O prime. So instead of this O prime B, you can write O prime A. Instead of OB, you can write OA. So your expression will look like this. O prime A by OA. And if you look at this diagram, what is O prime A, Uneep? Is it real depth or apparent depth? O prime A, Uneep.
Sir, apparent.
Apparent depth. And what about OA?
Sir, real.
So instead of this O prime A, you can write apparent depth and OA is real depth. So this is sin I by sin R, which is apparent depth by real depth. Yashika, just use Snell's law here and just tell me what is sin I by sin R. Use Snell's law in terms of refractive indices. Yashika. Yashika is not.
Sir, I'm there.
You are there. Just apply Snell's law and tell me how much is sin I by sin R in terms of refractive indices here. Apply Snell's law here. What is sin I by sin R?
Sir, NI by NR.
NR by NI. It's always refracted by incident. So when you use Snell's law, sin I by sin R is, just apply Snell's law in product form. Na? Here it's I, refractive index is NI, so you write this as NI into sin I, NR into sin R. So sin I by sin R is NR by NI. Now you can equate these two equations, this equation and this equation. So you can write that dA by dR is NR by NI. So apparent depth by real depth is refracted medium divided by incident medium. I'm saying again, refracted medium means medium which have observer. Incident medium means medium which have object. So this is the relation between the apparent depth, real depth, and the refractive indices. So if you want, you can write this as, like, you can write this NR in denominator, NI by NR. You can write this as NIR, which is refractive index of incident medium with respect to refracted medium. So dA by dR is 1 by NI. So you can say that if you multiply it over here, you can say that D apparent is D real by NI. And if you want to calculate shift, shift simply means the difference between the real depth and the apparent depth. This is shift. This is the shift. The shift is the difference between the real depth and the apparent. So when you take the difference, dr minus dA. So instead of dA, you can write dr by ni. Yeah? So you can take dr as common, 1 minus 1 by ni. This is the shift. dr 1 minus 1 by ni. So that is the derivation for apparent shift. Do it, then we will start the numericals.
It's not visible completely.
Just 1 second. Just 1 second. Should So the small derivation to relate the apparent depth and the real depth. Just 1 second. Just okay.
Sir, what is it written? Approximate. What is it?
Yeah, approximation near normal incidence, which means A and B are very small. Omar, if you want to understand this derivation, then you have to participate in class. Huh? Just switch on your mic. Then only you can understand the calculations.
Yep.
Did you draw the ray diagram?
Yes, sir.
Okay, in the ray diagram, can you see triangle OAB in your ray diagram?
Yes, sir. I see.
You can see, huh? So what is sin I? It's perpendicular by hypotenuse.
Yes, sir.
Just look at the diagram that you draw in your copy. What is perpendicular? Which side is perpendicular in triangle OAB?
Sir?
Yes. Which side is the perpendicular one in triangle OAB? AB is perpendicular,
That's
right?
OA. OA.
And what is hypotenuse? OB?
B.
Hmm?
Yeah.
So what is sin I? Perpendicular by hypotenuse? You can write sin I as AB by OB, right?
Sir.
This sin I is perpendicular AB divided by hypotenuse, right? Then take another triangle which is O prime AB. Just look at your notes, huh? Triangle O prime AB. What is perpendicular in this triangle?
Sir, O prime.
O prime B is hypotenuse. Perpendicular is AB.
A prime.
Sorry,
Oh, AB. AB. Sir.
AB
AB.
is the perpendicular and O prime B is the hypotenuse. How much will be sin R?
B
Perpendicular by
by.
base? AB by O prime
Yes,
B?
AB by O prime B.
Then just take the ratio. So AB will cancel out. This is O prime B by OB. Clear?
Yes.
Then we take approximation that points A and B are very, very close. It's near normal incidence. Rays are going very closely. So you can say that A and B are very close. So if A and B are close, then instead of this B, you can write A. This is A and B. Huh? This point A and this point B. I'm saying B and A are very close. So instead of B, you can write A. So it will be O prime A by OA. Instead of O prime B, you can write A. OB, you can write OA. So this is the expression O prime A by OA. Is it clear up to here?
Yes, sir.
Then O prime A is nothing. See, just look at the diagram. What is O prime A? That's D apparent. What is OA? That's D real. So we substitute the values. So this is D apparent by D real. Just note down up to this equation.
सर रे डायग्राम में जो मतलब ओ से बिल्कुल सीधी लाइन जा रही है परपेंडिकुलर पर वो मतलब क्या है क्या
वो रिफ्रैक्ट नहीं करेगी ना, जो नॉर्मली जाएगी वो रिफ्रैक्ट नहीं करेगी. नियर नॉर्मल मीन्स one ray which is passing normally, another is going very close to this normal.
Okay.
So the ray which pass normally will not refract, will go straight.
Protection down ना.
No, at least 1 hour. 45 minutes to 1 hour. So if you want, you can attempt that test from 7:30 to 8:30 before the class or after the class also.
Sir, it will be like NCRT based, so we can do NCRT for the practice.
Just based on exact pattern of CBSE. CBSE PQ and the type of question that's asked. Once this test series are over, we'll start the test series according to J. Because there is no point in giving those J questions if you are not even scoring your schooling. So Omar, up to equation number 5, is it clear?
Yes, sir. Yes, sir.
Okay, no, sure. Then next is after this, we use Snell's law. Snell's law is sin I by sin R is NR by NI. You know Snell's law, right? We discussed Snell's law in the last class. Then instead of this sin I by sin R, I just substitute NR by NI. That's it. I substitute instead of this sin I by sin R, I use Snell's law and put NR by NI. And then you can see when I make this substitution, dA by dR is NR by NI. This is what we were supposed to do. Arpit, Akshay, is it clear up to this equation?
Yes, sir.
Yes, sir.
Anshika, Noah, any doubt? Meher, any issue in calculation?
No, sir. Somewhere after this, I just bring this NR to the denominator. So you have NI by NR. So NI by NR is NIR, refractive index of incident medium with respect to the refracted. Can I scroll it? And this Ni by Nr is Nir. So your apparent is real by Nir. And shift is just the difference between the real depth and the apparent depth. The difference is known as shift. So everyone have written up to here? Nabil, Noha,
Sir,
Minashi.
in this case, we will also call the shift as lateral shift. Or not?
No, it's not. It's not a lateral shift. No. Lateral shift is the perpendicular distance between emergent and incident rays. It's not between the separation between incident and emergent rays. This is the position distance by which your objects get shifted. The coin was at the base, but due to refraction, it appears at some height above the base.
Yes, I got it.
That is shift. So it's not lateral shift. It's totally different. So everyone are written up to here? Anshika, Ishma. Okay. So let's do some numericals on it. Okay. After that theory, let's start with some numerical. So apparent depth. Do this question number 1. Let's start with this question number 1, straightforward thing. And no need to write question. I will share this assignment with you. On the group, I'm sharing the assignment. Question number 1. No need to write the question. I'll share this assignment on group. Question number 1. This is formula based. Answers. I'm saying again, no need to write question. I'm sharing the assignment in group also. Okay. Alia is correct. Okay, Alia. Answers. Okay, Arpit. Yashika, Uneeb, Noha, Nabil, answers. Okay, Akshay is also correct. Yes, Uneeb, it's correct. Right, correct, Mayor. Nabil, Ishma, Minashi, Omar, answers. Right, Ishma is correct. Yes, Adil, it's correct. See, just take the value of incident and refracted medium. Incident medium is the medium in which you have your objects. Your object is placed in a medium of refractive index 1.3. So you can write Ni as 1.3. Then Nr, refracted medium. Nr is it's air. If nothing is given, that means your observer is in air. Nr is 1. The apparent depth is this. The apparent depth is D apparent is 7.7. You need D real. So the relation that we have derived is it's D apparent by D real is NR divided by Ni. Just substitute the values. D apparent is 7.7. D real is unknown. N refracted is 1.3. N incident is 1. So you can write that your DR, sorry, N refracted is 1 and incident is 1.3. N refracted is 1 and incident is 1. So you can say that your D refracted is 7.7 into 1.3. So that comes out to be 10. Just note it down. Is it clear? This is formula based thing. Question number 3. Minashi, you didn't answer the question. Nabil,
Yes, sir.
you didn't answer the previous one. Solve this question 3 now. Again, don't write question, just solve and tell me the answer. Question 3.
So what is 4/3 like? The question.
Refractive index of water. Mu is refractive index. Is anyone solving this question or okay?
Just a minute, sir.
Okay. Yeah, Noah seems correct.
Sir, in third question, real depth is 1.5.
Nah. This is the length through which you are shifting it. Yeah, it's not the real or the apparent one. This is the shift.
Sir, microscope 1.5 से रेज़ फिर apparent depth भी 1.5 से रेज़
No, 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 no. This is the question means this is the beaker, huh? This is the point here, and this is the microscope. Huh? This is the initial position of microscope. Let's mark it M1. And this is the initial point of the position of the point. Let's mark it O1. Now he's saying that he's shifting the microscope by 1.5 centimeter. This is the second position. He shifts the microscope by 1.5 centimeter. Obviously,
Sir,
through this microscope, he can see the coin only if the coin or the point also shifts by 1.5 centimeter. Then only he can view it through the microscope. So shifting microscope by, and for this he is adding some water into it. So shifting water or microscope by 1.5 centimeter means he's indirectly saying that on adding water into the beaker, the position of the coin or the dot will shift by 1.5 centimeter. So he's indirectly telling you that the shift is 1.5 centimeter. Is it clear?
So can you explain again?
Yes. See, this is the microscope M1
sir,
position,
the
and
answer is 6.
yeah, answer is 6. Correct answer is 6. Almost everyone is correct. Nabil, Meher, Akshay. See, this is the position of the point, and this is the microscope. So the microscope which is placed here can view this point. Now he's saying that, okay, let's shift the microscope by 1.5 centimeters. So if you shift the microscope by 1.5 centimeter, obviously you cannot view this point. You cannot view this point. To view this point, microscope should be over this place. So he's saying, okay, to view this point, what you do, you place some water over it. So what water will do? Water will shift the position of the pointer. So if you are shifting microscope by 1.5 centimeter, then you expect that the position of point should also get shift by 1.5 centimeter. So that is the shift of your question. And how we calculate shift, we have derived a formula for shift also. Shift is the real depth minus apparent depth. So you can say this is 1.5. This real depth. What is apparent depth? Apparent depth is real depth into refractive index of the refracted medium divided by the incident. So you can say that 1.5 is the dr real depth, 1 minus nr by n. So 1.5 is dr, d real. This is what you are supposed to calculate. 1 minus nr. Nr means the medium in which you have your observer, which is usually air. What is Ni? Ni is the refractive index of water, which is 1.5. You can say that 1.5 is dr 1 minus 3 by 4. So 1.5 is dr. So you can write this as, if you divide it 4, 4. So dr by 4. So how much is dr? It's 1.5 into, and that will be dr. No, no. I'm sharing this assignment with you. This question number 4 would be your homework. Just note down the question number. Then after this,
6 will be your homework. Both on the same concept. Okay, so this is the concept of apparent shift. After apparent shift, the next topic is TIR, the most important topic. TIR. Total internal reflection. So for total internal reflection, two conditions are essential. The first one is the ray should travel from denser to rarer medium. And the second is angle of incidence should be greater than critical angle. So let's see what does TIR means. So this is your incident ray. It's traveling from denser to rarer medium. So when ray travels from denser to rarer, it bends away from the normal, which is very clear from this ray diagram that angle of refraction is greater than the angle of incidence. Minashi, what happens when we increase the angle of incidence?
Yes, sir.
What happens when we increase the angle of incidence? What happens with the angle of refraction? If I increase I, what happens with R?
It increases.
It will
Increase.
increase. I and R are directly proportional. So if I increase I, then R will increase. So if I keep on increasing this angle of incidence, the angle of refraction keeps on increasing. That means your ray will rotate in this way. If I am rotating your incident ray in this way, your refracted ray will rotate in this way. If we keep on increasing the angle of incidence, then there comes an angle of incidence which is known as critical angle, for which your ray starts grazing on the surface. This is your ray. Your ray will start grazing on the surface. Ray is grazing on the surface, that means your angle of refraction is 90 degrees. This is refraction. Still now, this is refraction. Now, if you increase the angle of incidence greater than the critical angle, if your eye becomes greater than critical angle, then what happens? Your ray will reflect back into the same medium. It will come back into the same. And this is what we call TIR, total internal reflection. So see, it's not refraction. Refraction means ray will bend. It will move from one medium to another. It's not bending. Your ray is not traveling from one medium to another. It's coming back into the same medium. Then that's why we call this as reflected ray. We call this as reflection, not refraction. And we call this as the angle of reflection. And by the law of reflection, angle of incidence and angle of reflection are equal. So I is equal to R, R is equal to. And TIR is 100%, which means if you incident millions of rays where angle of I is greater than C, then all rays will reflect back. But in normal reflection, it's not 100%. If you take a mirror, then mirror will not reflect 100% of the light. Only some 40, 50, 70% of the light can get reflected. Mirror also let the light to pass through it. But when you have TIR, it's almost 100%. That's why when you have any phenomena which is due to TIR, that phenomena is very, very bright. For example, if you take the case of the diamond shine due to this TIR, total internal reflection. So the phenomena which happens or which occur due to TIR are very, very bright phenomena because TIR happens almost 100%. Now, so this was the theoretical part. So what are the conditions for TIR? Your ray should travel from denser to rarer, the first condition. The second condition is angle of incidence should be greater than the angle of critical angle. And what happens at critical angle? At critical angle, your ray starts grazing over the surface. At critical angle, angle of refraction is 90 degrees. Now, when we see the mathematical part, in mathematical part, we can just calculate the critical angle. So we'll be applying Snell's law here over this point. So for critical angle, we apply Snell's law. So Omar, would you apply the Snell's law over point B? Omar, just apply Snell's law here
What, sir?
in product form. Apply Snell's law over this point B in product form. What is the angle here? C.
Just see.
What is refractive index here? The denser medium, you can write this as ND. So how will you make the equation in product form? You will write ND into sine C,
So
right?
it will be equal to
Right.
sin I.
Sine C, right?
Yes, sir.
Here it's rarer medium, NR. Angle of refraction is 90. You can write this as NR into sin 90. Right, Umar? Umar,
Yes,
is this
sir.
equation clear? This is Snell's law in product form, right?
Yes.
Sin 90 is 1. So what you can do is sin 90 is 1. So you can write ND into sin C as NR by ND, which I can write as 1 by NDR. NDR means refractive index of denser medium with respect to rarer. So this is the formula. Sin C is 1 by NDR. Sin C is 1 by refractive index of denser medium with respect to rarer. This is how we calculate the critical angle. Sin C is 1 by. So once you have this refractive index of denser with respect to rarer medium, you can calculate critical angle. And for TIR, your angle of incidence should be greater than critical angle. Say for a surface, for some medium, the critical angle is 30 degree. Then for TIR, your angle of incidence should be greater than 30 degree. Put it down. I'll do some numericals. TIR is very, very important for a plane surface. So the maximum chances of getting question from the plane surface is from TIR. And the next chances are from the apparent depth.
So, for DIR, so the angle of incidence, can it be 90 or it should be only more than 90? So you are not audible. No, sir. Still not audible.
Audible now? Yes.
Yes, sir.
Oh,
Yes, sir. Yes, sir.
Fine. So the angle of incidence will never be 90 degree. If angle of incidence is 90, that means your ray is grazing over the surface. You incident your ray in this way. Angle of incidence is not 90. Angle of incidence is greater than critical angle, which is less than 90 degree.
Okay,
If
sir.
angle of incidence is critical angle, then your angle of refraction is 90 degree, but your incident is never 90 degree. Because if your incidence is 90, then there is no refraction. Now your ray is actually you incident your ray over the surface. Refraction happens when your ray travels from one surface to another, one medium to another.
There's only one formula in TIR, and that formula is the sine C is 1 by NDR, nothing else. So always remember, for TIR, your rays should travel from denser to rarer. If your ray is traveling from rarer to denser, then there is no TIR. Second, your angle of incidence should always be greater than the critical angle. Written? Noah, Yashika, Nabil, Akshay.
Yes, sir.
Okay, let's solve this noisy. So this is just TIR, speed of medium.
Can you shoot for second?
Yes, yes.
Yes, sir, done.
Okay, do this. Question number 2. Sharas. Okay, I don't expect from you to calculate the angle in degree. You can write your answer in sine inverse only. I need answer in sine inverse. So you can just write your answer in chat room. Just do this calculation. I and write your answer in terms of sine inverse. I'm not saying to calculate this in degree. Just write your answer in terms of sine inverse also. Okay. So just one answer from Nabil. What about rest? Yashika, Noha, Munib, Umar. The formula based thing, yeah. The formula based thing. See, what is sine C? Sine C is 1 by n. What is n? Denser with respect to rarer. Right? So denser with respect to rarer means refractive index of denser medium divided by refractive index of rarer medium. So which one is denser? This glass is denser. 3 by 2 is more than 4 by 3. Okay. So this is 3 by 2 and R is 4 by 3. So it's 4 then by 3. So it comes out to be 9 by 8, right? So you can say that your sine C is 1 by 9 by 8. So you can say your sine C is 8 by 9. So the answer is C is sine inverse 8 by 9. So Meher was correct. Akshay is correct. Arpit is also correct. Nabil is also correct. No, Nabil, you are calculating. 9 by 8 you are writing. 8 by 9, nah? Okay, you're wrong. Akshay is correct. Minashi, you calculated the inverse. Okay. Is it clear now?
Yes, sir.
Oh, but this is very, very easy question. Huh?
Can you share this worksheet in the group?
Yes, I'm sharing the worksheet. The type of question that you usually get from TIR are not that simple. The type of question that you get from TIR are the questions which have two refractions, one TIR and one refraction. Is that question? That question. See this question. See the question number 3, the solution of 3. Question number 3. So you have a glass slab. This is your glass slab. He's saying that a light ray is incident over this face of the slab. This is some angle of incidence I. The ray will get refracted. The ray will get refracted. So this is the angle of refraction. The ray will get incident here, and he's saying that ray is grazing over this adjacent surface. The ray is grazing here. He's asking you to calculate the critical angle of the system. And also the refractive index. The rarest medium is air. So the refractive index is 1. The denser medium is glass, and the refractive index of glass is 4. So you're supposed to calculate C as well as the refractive index of the glass. This is a tricky question. So you have one refraction and one TIR. So in these type of questions, what we do is we always start from here. We always start from the end where you have TIR. Is this ray diagram clear? Then only I can start the calculation.
Yes, sir.
Akshay?
Sir, can you
Vishwanath?
explain the ray diagram again?
Yes. See, this is a glass slab. The ray is incident over this horizontal surface. This is the angle of incidence. Ray is traveling from air to glass. It will bend towards the normal. Then ray comes here. This is the refraction and the ray comes here. Then he's saying at the adjacent face, the ray is grazing. The ray is grazing means the angle of incidence here is equal to critical angle. Then only ray will graze. You're supposed to calculate this C and the refractive index of the glass. Clear now?
Yes, sir.
Okay. Now, can you relate this critical angle with the refractive index of glass? See, what's the relation between critical angle and this thing? Sine C is 1 by refractive index of denser with respect to rarer. So what is denser with respect to rarer? That means refractive index of denser medium divided by the refractive index of rarer. In our case, the denser is the glass and the rarer is the air. So NDR is NGO. So we can say that sine C is 1 by refractive index of glass. That's science. So let's call this as equation number 1. We know this I. So somehow we have to relate this I through this C. To relate I and C, what we can do is a right angle triangle. It's a very, very lengthy problem. See, it's a right angle triangle. So R, this 90 degree and this C, when you add them up, it becomes 180 degree. So R, the sum of 3 angles of triangle is 180. So R plus 90 plus C is 180. So you can say that your R is 90 degree minus C. Or you can say that your sine R is sine of 90 minus C. And sine 90 minus C is cos C. Let's call this equation. So important equation. Now we know sine R is cos. Now let's apply Snell's law over this surface, P1, P2.
Snell's law at P1, P2. Snell's law at P1, P2. So let's apply Snell's law here. Here this is A, the refractive index is 1. So this is 1 multiplied by the angle of incidence is I, 1 into sine I. In another medium, the refractive index is some Ng, glass, multiplied by the refractive index is R. Sorry, angle of refraction. This is equation number 3. Next, what I can do is I can just substitute sine R in from 2 to 3. So when I substitute 2 in 3, I get sine I is equal to refractive index of glass multiplied by cos C. Let's call this as equation number 4. Next, what we can do is, see, here we have cos C, but we don't need cos C. We need sin C because we know how to relate sin C and the refractive index. So can you convert this cos C into sin C somehow? Sin square C plus cos square C is 1, right? Sin square C plus cos square C is 1. So you can write that cos C is root over 1 minus sin square C. Let's call this as equation number 5. We know that sin C is this 1 by ng. So let's substitute 1 in 5. So when we do the substitution, we get sin I is ng. It's root over 1 minus sin C. Sin C is 1 by ng. So 1 by ng square. So we have sin I is ng root over, when we take LCM, this is ng square. So we have ng square minus 1. This is whole in under root. So when you take it outside, it becomes ng. So you have sin I is ng divided by ng, refractive index of glass, root over refractive index of glass square minus 1 gets cancelled. So I is given sin 70. Is in numericals, if 70 is given, then you will be given the value of sin 70. So you can take square on both the sides. You have sin square 70 degree, which is ng square minus 1. So from here, you can write that ng square is sin square 70 plus 1. So now you have ng. Refractive index of glass is root over 1 plus sin square 70. This is the type of questions that one can get on TIR. You
This
don't,
was very
you will,
difficult.
it's not difficult, just lengthy, it's a lengthy calculation. So in TIR, you don't get formula-based questions. You get questions in which you have one TIR and one diffraction. Great. No need to write the question. I'm sharing this on the group. I'm sharing this on group. Note it down in where I'm sharing the assignment. I've shared the assignment on group. Huh?
So on Wednesday, you have test of chapter number 3. Next Wednesday, chapter 4, then 6th, then 7th, then wave optics. Meanwhile, I'm sharing a revision assignment of current electricity also. So if you want, you can just practice some questions from that assignment. If you want, you can take the screenshot. Let's stop this class here. Let's take screenshot from here.
Sir, can you show the figure?
Okay, so let's stop here from this